welcome back and thank you for joining. Let's practice some questions where we have to convert mixed radicals into entire radicals. Remember, mixed radicals are expressed as a product of two terms where one is in radical form and the other is in a non-radical or regular form, let's call it. So to express this as an entire radical means that we need to write it as a radical with a coefficient of either plus or minus 1, but nothing else in front of it. So we have discussed the strategy of how to convert mixed into entire radicals in class. So if you want to, you can go back to the lesson. And I brought them back in here so we can refresh our memory. Step number 1 would be to identify the index. So the index in our case here is equal to 2. The reason why we want to identify the index is because we want to bring the regular number or regular term inside the radical of the same index. So step number 2, we're going to bring the number outside the radical to the power of index. That's how we'll be able to bring the regular term inside the radical. So in other words, we're going to take this number 5 that we had right here and we'll bring it to the power of 2, and then because that became now a 25, we'll quickly undo the damage by square rooting 5 squared. And then we still have the square root of 5, which is this little number here. And continue simplifying a little bit. The square root of 5 squared would be equal to the square root of 25. And then we still have the square root of 5 here. So next we have to combine the two radicals using the formula. The nth root of a times nth root of b is nth root of ab, and write it as an entire radical. So here we go. This would be equal to the square root of 25 times 5, and 25 times 5 equals 125, and voila, we have an entire radical with coefficient of 1. Let's move on to the next question. So again, identify the index. So index is 2, which means that the number 2 that we see in front of the radical must be brought to the power of 2. And then square root it, so it maintains the same value. And then we still have the square root of 7. Simplify, so we have the square root of 2 squared, which is 4, times square root of 7. And now combine into the same radical, 4 times 7, and that would be equal to square root of 28, entire radical. Now let's take a look at this interesting question. This time we have a minus in front of the radical, which means that the non-radical term is negative. Now remember that once this is brought inside, we cannot bring it out as a negative, which means that this negative sign will stay out. And the number 3 and only number 3 will be brought to the power of the index, which is 2. And we'll quickly again undo the damage. So this would be the square root of 3 squared, and we still have the square root of 11. Okay, so again the minus sign will stay outside. We'll have the square root of 3 squared, which is a 9 multiplied by the square root of 11. So this would equal negative the square root of 9 times 11, or in a more simplified form, negative the square root of 99. Voila, this is the entire radical. This time it has a coefficient of negative 1. Now for root 2, so I think we kind of got a hang of it. So we have the index 2. That means number 4 will come to the power of 2 and square root it. So the value of it stays 4. And then we have square root of 2. So that would be root of 16, root of 2, or root of 16 times 2. Or even better, square root of 32. Next question, let's see how many we have. So we have index 2 again. Let's make it red. Stay consistent. All right, so we have 3 now that should come to the power of 2 and square root it, and square root of 7. So That would be the root of 9, root of 7, or the root of 9 times 7, which is the square root of 63. Let's do the next question. This time we have index 3. So what that means is that this number 3 in here will be brought to the power of 3 and quickly cube rooted again. So as you can see, we still have the same number value, so number 3. And then we have the third root of 2. Don't forget to write the index when it's different than 2. So this would be equal to the third root of 3 to the power of 3, or the third root of 27, multiplied by the third root of 2. That equals the third root of 27 times 2. And 27 times 2 is 54. And before you finish the question, make sure that you have checked all the indices and make sure that they're right and they're there. Okay, next question. We have a minus. Okay, now remember that this time, since the index is 3, we are allowed to bring negatives in because the index is odd, and the odd roots of a number can be negative as well. So we're going to bring the number negative 2 to the power of 3 and cube root it. Okay, so the negative sign in here, in case we're still wondering, right, can come inside the radical because odd indices welcome all kinds of numbers, positives or negatives, okay? And still multiplied by the third root of 5 in here. So that would be equal to third root of negative 8, third root of 5. And third root of negative 8 times 5 would be equal to the third root of negative 40. And that would be the answer. Let's try one more. We have index 4 this time. In front of index, we have number 2. So that means we have to bring number 2 to the power 4 and quickly fourth root it, because we need to keep the same value for this number. Now we still have the fourth root of number 3. So simplify a little more. We have the fourth root of 16 multiplied by the fourth root of number 3. So that would be the fourth root of 16 times 3. That would be the fourth root of 48. And that would be the entire radical. I hope this made sense, and please follow for the next or for the rest of the questions from the practice on lesson UNL9. Bye for now.